Good evening, ladies and gentlemen. I hope you are well. My name is Julius, and I did my fellowship project with the trade desk on the topic of advertiser spending. 350 million, that is a big number. How does it relate to this project? I will explain that in just a minute. The trade desk places internet advertisements, and it works with a huge number of brands. Important to note here is that the trade desk gets a certain daily budget for each advertiser campaign. It spends that daily budget in a process called real-time bidding. In real-time bidding, a user visits a website, and the advertisement slots on that website will be auctioned off in real time on an advertisement exchange. The trade desk submits a bid for one of its campaigns, and so do the competitors. And if the trade desk wins the bid, then the ad is delivered in time to the user who is happy to see the advertisement. And the whole process takes just 100 milliseconds. So some of you may have thought that the 350 million referred to a certain bus, but actually it's the number of real-time auctions that the trade desk processes every single minute. That is the problem of an enormous scale. And so one of the key challenges is, how is each individual campaign paced throughout the day? Ideally, you would want to spread the daily budget across the day so that the budget is empty at the end of the day, and the advertisements run throughout the day without any breaks. However, if you overspend, then your budget may be blown away after the first 10 minutes of the day, and you don't have anything to spend later on. However, even much worse is if you underspend the budget, because in that case, the budget, you've got money left at the end of the day, and that has a direct financial implications for the trade desk, and the advertisers are very unhappy as well because they want to see their advertisements placed. So in order to make sensible, in order to pace the campaigns in a sensible way, you need to make a good prediction as to how much spending opportunities you will have for the day. And the problem is that the current trade desk models causes underspending of around $2 million. So the aim of my project was to improve that prediction so that the campaigns can be paced in a better way, and so that the underspending can be reduced. The data that I received were 3 billion data points overall, covering the spending amounts for every 5 minutes for the past 45 days from 280,000 campaigns. And it's important to note that, as expected, campaign spending throughout the day varies a lot, but also that in between campaigns, campaign can look very different. Also, if you look at just one campaign, then you will see that there are daily patterns that repeat themselves over the day, so that the spending at 3 p.m. on Monday will probably be quite similar to the 3 p.m. spending on Tuesday and on Wednesday. So the aim for my model was to predict the hourly variations within a day, but also make use of the fact that there are daily patterns that repeat themselves. And at the same time, the model needed to be able to be computed efficiently and fast, because it is supposed to be run at scale. So because this amount of data does not fit on a single desktop, I used Spark on Amazon cluster to process the data and work with the data. I then developed a performance test for a large number of different models, from linear models to ARIMAs, STLs, up to neural networks. And in the end, I determined the best model based on its accuracy and on its computational efficiency. It turns out that the model that I developed improves the underspending so that only $500,000 are underspent for all campaigns, rather than $2 million, which was the starting point. In addition, as the campaign goes on and the model is fed with additional data, the performance of the model improves over time. So what was the impact for the trade desk? For the trade desk, I've been able to show that machine learning can be successfully applied to large-scale problems in real-time bidding. And my model was able to reduce their underspending by 75% or $1.5 million. Thank you very much.